Okay, in problem number 5, for time between 0 and 31, the rate of change of the number of mosquitoes on tropical island at time t days is modeled by r of t is 5 square root of t cosine t over 5 mosquitoes per day. There are 1,000 mosquitoes on tropical island at t equals 0. First, we want to show that the number of mosquitoes is increasing at time t equals 6. So we state that the number of mosquitoes will be increasing when r of t, which is the rate at which mosquitoes are changing, is positive. So the first thing I'm going to do is enter that function in the calculator. Now I want to find if at time t equals 6 r of t is positive. So all I'm going to do for this is go to the main screen, and I'm going to vars, yvars, function, y1, and evaluate that function at time t equals 6, and I get 4.438. And I state that since r of 6 is 4.438, this is true. That is, that the number of mosquitoes is increasing at that time. For part B, we're asked at time 6 if the number of mosquitoes is increasing at an increasing rate, or if the number of mosquitoes is increasing at a decreasing rate. So we know that the number of mosquitoes is increasing at t equals 6. What we're asked about here is the derivative of this derivative, the rate of change of the rate of change. And so what we need to find is the derivative of r, or r prime, at time t equals 6. One of the easiest ways to do that is to go into Math, and option number 8, put in vars, yvars, function y1, comma x, the variable that we are differentiating with respect to, and 6, close parentheses, and since that value is negative 1.913, so we state that since r prime of 6 is negative 1.913, the number of mosquitoes is increasing but at a decreasing rate. Since the second derivative, even though we're taking the first derivative of r itself is a derivative of the number of mosquitoes. So the number of mosquitoes will be concave down. And even though it's increasing, it would look something like this, where the curve of the number of mosquitoes would be modeled by the blue line. And since it's concave down, even though we're increasing at this point in time, the slopes are going to be gradually decreasing, and eventually will lead to a decrease itself in the number of mosquitoes. So we would say that the rate of increase is slowing down. For part C, we're asked to find how many mosquitoes will be on the island at time t equals 31 and to round our answer to the nearest whole number. Well, since r is the rate of change of the number of mosquitoes on the island, what we need to do is to first consider the number of mosquitoes that we start with, which is 1,000, and then take the integral from 0 to 31, and that's going to give us the number of mosquitoes excuse me, on the island at time t equals 31. So since we're already at the home screen, we might as well just use fnint, and so we go Math, option 9, then vars, yvars, function y1, comma the variable that would the variable of integration, which is x, from 0 to 31, and we get that the final result is negative 35.665. So we add to that 1,000, and we're at 964, rounded to the nearest whole number. And so that is the final answer to part C. And we'll continue with part D in the next video.